So today we will revise what we did last time. More importantly, we will ask basic questions in the beginning and the advanced questions in the end. So anybody has questions about the very basic constructs like variables or something? So we have, let me write down variables, loops, and conditions, like actually these are statements, condition statements, like for, and I'm not going to, we can talk about everything, but gradually let's not overwhelm ourselves with every possible constructs. And then we have this conditions, like x equal to 2 or y equal to 3. This much we did last time. Anything I missed?
List.
Data types like integer, real, or float, or fractions, and list.
Excuse me, sir. I have a question.
Kaide bolo.
Sir, you used the term for loop last time, but I didn't get it. So.
Okay. Sure. We'll talk about it. Anyways, I'm going to talk about all of them again. And tuples. So let's talk about variables. Okay. Again, this whole, most of you must have heard about memory, correct? Correct? RAM.
Yes. Yes, sir.
Anybody not aware? Please talk. Then I can explain that first. So let us say we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9? 3. Okay. So we'll just give it a number. So now, so this is row and column. So suppose can somebody explain me if I have to place something here? Okay, I'm on phone with somebody, not sharing my screen, and I need to put a number here, 3. Can somebody explain me how do I tell other person on the phone that right here?
Sir, may I?
Yeah, please, Ashna.
Sir, with the cell address of the particular cell.
Yeah, good. So you tell me how we can identify this as a cell address.
Sir, with the column number and the row number, we could say
Yes.
enter a specific number to row number 4, column number 3.
Correct. This is precise. So if I want to write like this, I will say, I will depict it like this. And if somebody wants to say, okay, right here, I will say row number 4, column number 3, write 3. The other person on the phone will be able to get it and he will write it here. But this is how the whole RAM is distributed. RAM is basically a kind of a matrix which has, I will not call it a matrix, but I will call it a singular one-liner kind of a thing. So we usually distribute it in the form of a row and column in your mind. So what we do is, suppose
Hello.
we are
yeah. Udyan, please let Karthik inside. He is waiting.
I don't see actually. I did not see any invite. That's why.
Okay, I'll tell him to join again.
If I see, I will see a pop-up kind of thing on the screen. Correct. I never found any.
Okay.
Okay, got it. So this is how we do addressing. So most of the time, hi Gadik. Okay. So now most of the time we identify something like this. We will say row number this, column number this. Suppose we have to go here. It will be row number 5, column number 5. We're going to call it. And I'm deliberately using brackets around it. And if you see, it's a tuple. Or if I have to do it here, I will say row number 1, column number 2. But the funny thing, what happens in programming is or programming 2 programming is sometimes they start cells from 0. So you will find 0, 1, 2, something like that. This way, they just want to maximize the variable utilization or memory utilization. And it's a very small thing, but it actually makes a lot of sense. How many of you actually understand binary numbers? Raise your
I
hand.
understand what is binary.
Good. Who else? Aida?
I do. I understand.
Sir,
Okay.
do you mean what about that? How we understand that what is the binary code or what are binary numbers?
Do you understand?
Sir, I understand binary numbers.
It's a binary code. Same thing. Who else? Saideep? You understand?
So actually, I was trying. So
Okay. So how about this?
I don't understand.
If you want, all of you take a vote. If you want me to go detail in the numbering system, how binary number actually plays a big role in the computer science, I can talk about it maybe next week. Okay. So take a vote within your team and talk to each other. Okay. Now try to understand if we are storing, and I'm just, this is 0, 0, 0, 0, is 0, 0, 0, 1. And if you have to store, this is 15. Correct? And the moment I add 1 to it, the number of digit will be, I will need to add one more digit to it. You see that? I will have to add one more digit to it. So don't worry about how am I basically calculating it so quickly, because I'm used to and I do it every day. I still do it. I still use it every day. So what happened is the moment we start one number to 15, we wanted 16. What happened is I need one more place to store that number. Now look at this one. Suppose I have to store 8. I will be 0, 0, 0, 0, 0, 1, and 8 is 1, 1, 1. Actually, 4 plus 2 plus 7. So now, if I start numbering like this, I actually save. So suppose there are 8 cells. So I will store, instead of 1 to 8, I will store 0 to 7. This is the fun part. Because if I add 8, 1 to 8, the 8 will be like this, and I need extra storage just for one digit. Now, if I use 0 to 7, I need 3 digits to store it. If I need 1 to 8, I need 4 digits to store it. This is the fun part. How many of you have understood this thing, and I will explain to others who have not? How many of you have understood? Raise your hand. Good. Who else? Aida? You understood? Ashnur?
Yes, sir.
Good. Gatik, you understood? Sandeep?
Yes, sir.
No, sir, I didn't get it.
Okay. So let us say, in order for us to store 3 digits, in order to store 8, 1 to 8, we need 4 digits. But if we have to store from 0 to 7, we need 3 digits. If we just accept it, let's not worry about how it is. But if you see, in order to store 0, 0, 0, how do we calculate? So if you see the first digit, 8 multiplied by 1 plus 4 multiplied by 1 plus 2 multiplied by 1 plus 1 multiplied by 1. So 8 plus 4, 12, plus 2, 14 plus 1, 15. This equates to 15. Okay, for 8, let's look at the 8. Where is 8? Let's look at the 8 here, which is actually we are storing it as a 7. We will need 1, 4 multiplied by 1 plus 2 multiplied by 1 plus 1 multiplied by 1. And I think we can have a session on binary number next week. So this is how this depiction will happen, this thing. So 111, each digit is multiplied by its positional value and you get 7. This is the interesting part, that you get 7. Here you get 7 and here you get 15. Now, instead of storing 1 to 8, because the moment I need 8, I have to have one more digit here. So what happened is I am forced to add more storage to it. This is exactly some of the programming language. We who are very, very respectful to the resources will leverage this. So you need to understand there are two kind of programming language, high level and another is low level. Low level does not mean diminishing or basically bad, but the lower is closer to the hardware and the higher is closer to the user. This is the only difference between lower level. So if you use C comes in the medium, but it is more lower than the higher. C and C plus, actually C only. And assembly is very lower, very, very lower, because you write the entire code almost, and there is another top below this. I forgot the name for that, but that's absolutely in binary. And by the way, my initial time when I started with the lower level code where I used to write 0010. We didn't even have any text in it. And then we moved to assembly and then we moved to C. So what happened is, at that time, we were very conscious because the RAM in my desktop was 16 KB. Guys, 16 KB RAM. It's, I think more digits are there in the Lego blocks right now. So 16 KB is not even fraction, is puny. Usually a chip of no use will have that kind of RAM these days. But your mobiles have like 10 gigabyte, 20 gigabyte RAM. My desktop which I bought is around 64 gigabyte of RAM. At that time, for me, losing a single bit for each line is going to cost me a lot. That was my RAM, and my highest storage was 1.4, actually 1.2 MB. This was my hard disk. So try to understand there is a scarcity of storage. Now we might have huge amount of storage, but if I have to deal with the system, suppose I miss one bit. Let us say I am very careless and I start using from 1 to 8 instead of 0 to 7, and I lose one bit on each variable or each cell. If I have a matrix of 16 million, 10 million by 10 million, if I have a matrix of 10 million by 10 million, which is 1 crore by 1 crore row cells, each cell, if makes me lose one bit, this many bit, which is 10 raised to the power 14 raised to the power 14 cells total. A matrix which is 10 million by 10 million is 1 crore by 1 crore. 1 crore is 7 digit, million is 6 digit. So this is this many cells. If I lose one bit on each of those, I will be losing this many bits. So if you divide it by 8, that many of bytes you're going to lose, which is humongous. And when you go to latest system, if you see ChatGPT, can you imagine ChatGPT has 170 billion, 175 billion. I hope you know what is billion. 10 to the power 9, correct? Okay, so 175 billion parameters. And each parameter, if you lose one cell, one pixel, you will end up losing 10 to the power 9 cell. And the cost per day is 700,000 USD per day. The running cost of ChatGPT 3.5 at this point of time is $700,000 a day. If you multiply by 80, you get in rupees. The whole year budget will be more than the state budget of many of our states. So you have to understand that even though it looks very puny, that what do I gain out of one cell, we actually save a huge amount of storage. In nutshell, when we are writing bigger solutions, because when we are dealing with population, we are dealing with like India itself is 1.4 billion. And a storage system which is going to process all of them in one go is going to need 1.4 billion pixel or bits extra if I am not respectful to the storage. Got it? So this is why in order to save storage, they use 0 instead of 1. And some programming languages which are not careful, which do not worry about storage, which do not respect that there is a scarcity, we do not expect that I will be working on a very heavy system. They will start with 1. Like Python is different when you are using C is different. So this is what you have to understand, and that's why Python starts from 0. So if you see any code, you will always find 0 as the first cell.